Okay. So what is a non-binary predicate? What is a non-binary predicate? What is meant by binary predicate? A predicate having two variables is called a binary predicate. Okay. Others are non-binary predicate. So the semantic nets are natural way to represent relationship that would appear as instance of binary predicate. That is, using semantic network, we can easily represent binary predicate logic. Okay. So, for example, these are the examples. As in the previous class, we discussed the examples. Okay. So, uh, so in this class, we are discussing which are the different ways to represent non-binary predicates. Okay. First one is unary predicate case. Okay. For example, this is a unary predicate. That is only one symbol inside the bracket, which is a person name. Okay, Marcus. Marcus is a person name, which means it is a particular instance of the man class. Okay, so using that concept, we will convert this man inside bracket predicate to this format. Okay, so Marcus is an instance of man. Okay, what is meant by an instance? Instance is actually a particular object within a class. Okay, so we can represent in this way. Then now this is a binary predicate, so we can easily represent this in the form of a semantic network. Okay. That is the logic we want to apply. Okay, for how to handle the predicate having single variable. This is the logic. We will first convert it into the binary predicate. Okay, then we will draw the corresponding semantic network. Okay, next case is three or more place predicates. Okay, now we are going to discuss about the a binary predicate having three variable. Okay, three variable. That is called the three place predicate. Three place predicate. Anyway, this is an example. Okay, for example, this is an example. Here, you can note this. There are two teams. Okay, one is Cubs. Okay, this is a team name. Okay, this is a team name, Cubs. This is another team name, Dodgers. Okay, two team names. That is, two teams are there. They played a game. Okay, they played a match. Okay, they played a match, and one team win over other team by a score 5-3. Okay, they played a match or they played a series. Then one team win over other team by a score 5-3. Okay. How can represent that knowledge? Okay. So here already the predicate corresponding predicate expression is given. Okay. So two teams, Cubs and Dodgers, played a series, and one team win over other team in the score 5-3. Okay, so how can represent it? So this is the you can note this format. Okay, this is the corresponding semantic network. This is the corresponding semantic network. Okay, 1 minute. This is the corresponding semantic network. Okay, this is the corresponding semantic network of this. Okay, this one. This is the predicate logic expression, and this is the corresponding semantic network. How can draw which are the different nodes and which are the different relationship? Okay, so we want to convert this into a semantic network. So we need to find out which are the different nodes, okay, or which are the different concept, and which are the different relations, okay, in it, which means which are the different nodes and which are the different labeled arcs. So we will always express, first of all, you should note that we will always express the 3 variable predicates in this format. Okay, in this format we will express. Okay, so here you can note there is a team Cubs. Okay, there is a team Cubs. This Cubs is written here. Okay, it is written here. We created a node for the team, and okay, just note this. Okay, another is Dodgers. Okay, another is Dodgers, and we created a node Dodgers also for Dodgers also. Okay, next there is a game class. Okay, we know it is a game. Okay, there is a game class. Okay, there are different games are there. Okay, one is cricket, and there is baseball, and there is football, etc., etc. So what we want to do is that we want to create a game class. Okay, game class, and we are writing in this way G23. Okay, I just given a name. Okay, I can give it as baseball, no problem. Baseball. Okay, I can give it as baseball. Baseball is a ESA. Okay, ESA means it is a subclass of game. Okay, baseball is a subclass of game. So I created a game class, then I created a subclass, and here I named G23. I can give any name. Suppose I can give an baseball. I can give it here baseball, no problem. So, and I created a relation is a. Okay, is a, is a. Then this is Cubs team. This is Dodgers team. And I created another 2 relations. This arrow mark indicates the visiting team. Okay, this is the visiting team, and this is the home team. In this way, I expressed the relation between these nodes. One is the visiting team, and the Dodgers is the home team. I can give any relationship. Here I given visiting team relation. Here I given home team relation. How this how Dodgers is related to this game? It is a home team. Okay, it is a home team, and Cubs is a visiting team. Okay, then I created another node. What is this node? You can note this is the third symbol 5-3. This is the winning score. Okay, so 5-3 is represented as additional node, and from 5-3 I created a node from this relation I defined. This is score relation. Okay, this is score relation. Score. Here score is there. This is the score relation. Okay, so this is the corresponding representation of a 3 variable predicate. In this example, this is the corresponding semantic representation of 3 variable predicate. Okay, so This procedure is common to all type of three variable predicate. Okay, so just analyze what we have done. Just analyze. First, we created a node for cubs. Another is dodges. Then I created a game class. Okay, this game class is defined. Then I created another node, baseball or G23. It is a easy relation with the game. Okay. Then I defined the relationship between G23 or baseball and Cubs. I defined the relation is visiting team, and this is home team. Okay. So this is visiting team, this is home team. Then I created another node 5-3. Okay, this is the score, and I defined the relation score. This is the predicate. In this way, using this logic, we want to convert the three variable predicates, to semantic network. So, for example, we can discuss another example. Okay, this is one example. Usually in the university exams, this type of questions will come. Okay, this is a very important topic and very important question. Usually they will ask one question from this section. So, please understand the concept. Next, we can discuss this one. Okay, for example, John, you can note this. John gave the book to Mary. Okay, John gave the book to Mary. This is the sentence. This is an English sentence. Okay, John gave the book to Mary. So, John is the person or agent, and who is the beneficiary? Mary is the beneficiary. Okay, note that point. John gave the book to Mary. John is the agent, and Mary is the beneficiary here in this sentence. Okay, and the book is the object. Okay, book is the object. What is the action? Gave is the action. Okay, so first of all, you should understand the sentence. Okay, John gave the book to Mary, which means John is the agent. Who is the beneficiary? Mary is the beneficiary. The object is book, and the action is gave. Okay, so this is the corresponding representation of in predicate logic. Actually, an English sentence is given. So, if you want to convert this into a semantic network, first you write the corresponding predicate logic expression. Okay. So, here you can note gave in bracket John. John is actually the agent. Then book is the object, and Mary is the beneficiary. Okay, so you can note this. Okay, note this. This type of sentence is expressed in predicate logic using in this way. Then what we will do? We will try to create the semantic network. Okay. We will try to create the corresponding semantic network. Okay. So this is the semantic network corresponding to it. This is the semantic network. Okay, corresponding to this English sentence. John gave the book to Mary, and corresponding binary predicate. Sorry, corresponding three variable predicate. Okay. So how can write it? As usual, first we want to create a node John. Okay, John. Another is Mary. Okay, John, Mary. Okay, John, Mary. There are two persons, and give is the action. Okay, give is the action, or gave is the action. Then we will create you can note this EV7. Okay, what is EV7? You can give is a class of actions. Okay, try to understand this concept. Okay, give is a class of actions. Okay, give. Okay, so we create a particular instance of give here, EV7. EV7 is a particular instance of give action. Give action. EV7 is a particular instance of the class give. Note this. Then this relation is defined as instance relation. This relation is defined as instance relation, because EV7 is a particular action in the give class that belongs to the give class. So this is the first thing we want. This is the next thing we want to do. So we created a node John. We created a node Mary. Then we created a class give, and a particular instance of give is created, and it is given as EV7. Okay, EV7. Then what we will do? Then we will. There is a book. You can note this book. Book means there are different types of books. Okay, so book is actually a class. Okay, book is actually a class. So we want to create a particular book. Okay, this is BK23 is a particular book of the book class. So it is defined as an instance. Okay, then what we will do? Then we will try to define agent. So here in this action, who is the agent? Who is starting the action? John is starting the action. So John is defined as the agent. And who is the beneficiary? Mary is the beneficiary. So we will define the beneficiary in this way. Okay, in this way we will represent the relation. Okay, here it's not needed. Okay, this is the relation. Okay, you can note this. This is the relation. Okay, so beneficiary is also defined. Then another is how this particular book BK23 is related to EV7. It is an object. The relationship between this is EV7 is a particular action of give, and it is related to book 23 in the way that it is an object. Okay, so this is the method of representing this type of sentences. John gave the book to Mary. Okay, similarly in the previous slide we discussed the same concept we applied here. Same concept we applied here. So what is the use of this central node? Anyone thought about this? What is the use of this central node? Here we created a G23. Okay, similarly here we created a EV7. What is the use? Why we are creating such a type of node? Why? What is the significance of that node? What will be the significance of that node? That is, we want to convert the 3 variable to 2 variable. Okay, if there is a if there exists a node like this, then we can convert or we can represent it as a two variable predicate. That is the use. Okay, that is the use of this node. That is the importance of this node. There is a central node EV7 here. There is a central node EV7 here, and there is a central node EV7. Okay, what is the use of EV7? What is the use of G23? Because for converting 3 variable to 2 variable predicate, we are using this node. Okay, so try to understand the use of that. So this is about the conversion of 3 variable to 2 variables. 3 variable representation of semantic network. Okay, 1 minute.